Welcome to Mr. Lamb's Science Corner. Today we're going to do a few demonstrations. The first one we're going to start off with basically just putting some pepper on the top of the water. And most of the pepper will float even though pepper itself is heavier than water. Denser than water, I should probably say. What I've done now is you see maybe a little bit down on the bottom, but you see the vast majority of the pepper is floating on the water. And I've told you that pepper is heavier, denser than water. So you might well ask, what's going on? And the obvious answer is, of course, our old good friend surface tension. The surface tension is keeping the pepper on the surface, and there's another demo that we'll do some other time, that a couple of demos actually that work quite well. But for right now we're taking a look at the pepper, and as it turns out, water is not as wet as you can possibly imagine, which is an incredible statement, and your students will probably hoorah about that, but it's true. The water is not as wet as it could be. And to show that is this demonstration. So we've got pepper, and I bought coarse ground black pepper because coarse ground seems to be a little better, and of course this goes on our table for use later. Fine ground may not work as well. So the coarse ground, although I would certainly not want to get peppercorns or anything like that, but coarse ground seems to work pretty well. And I also have some soap. This happens to be ivory because I'm very much a traditionalist, and ivory is 99 and 44 100ths pure, which even as a kid I wondered, what about the 0.56%? What is it made of, and why is that pure? But be that as it may, ivory. You may want to get for your classroom, you may want to get some Joy or Dawn, because it's just as cheap, if not cheaper, than ivory, and it also makes a great bubble soap. Ivory doesn't seem to make as good a bubble soap as Joy or Dawn does. But for this one, any soap will do. Liquid soap is better than bar soap. And what I'm going to do is I'm going to pour in some soap. And what I have is I have a fair amount of the pepper has sunk. Not all of it has, that's true. It's probably about 50-50. I will tell you that when I was a chemistry teacher, the demonstration that I did was this with what they call flowers of sulfur, which basically is powdered sulfur. They go dig down into a sulfur deposit area, melt it, bring it up, spray it into the air, and what comes down is powdered sulfur. And the sulfur does the best job possible, but I don't happen to have access to the sulfur anymore, and so pepper works reasonably well. And the reason that this sunk is because the soap has reduced the amount of surface tension. If you reduce the amount of surface tension, then at least some of the pepper will sink. Okay, now let's see if I add a little bit more, if that will help it sink, and it doesn't appear to be doing that. So we'll just have to put up with the fact that we had about half the pepper sink. And this has a practical use. If you talk to the local firemen, they'll say that at times that they will add a little bit of soap to the water because that makes the water more penetrative, and it's able to get in deeper into whatever's burning and put it more thoroughly out. The story I like to tell from the local area is that we had a small forest fire. We live in a forested area. Klamath Falls, Oregon has lots and lots of trees. And north of here is a little town called Chemult, and they had a forest fire, and they went out in the fall, and they went out and they put it out, and they diligently came through later and do a lot of chopping, and they have these people with 5-gallon cans of water on their back, and they go out and they put out all the hot spots. Well, unfortunately, as happens sometimes, they missed at least one of the spots. And fire is really strange. It's weird and wonderful. It actually will start burning down in through the roots underground, and there's enough air in there, if the soil is just the right thing, that it'll continue burning the roots. I saw this happen at scout camp. We came back, we had hot spots the next day where we had campfires. We didn't dig down to mineral earth the way that we were supposed to. And so they had burning roots that they didn't know about. And that winter, we happened to have had, here in Klamath Falls, what has to be pretty close to a record snowfall. We had 101 inches of snow, 8.5 feet. Chemult, being higher and a little more rural, had even more. So I'm not exactly sure how much they had, but it was at least 12 feet of snow. So here we have the ground, 12 feet of snow on top of it, and underneath the roots are still smoldering. And so then, the springtime, all that snow melted, all that water came down through the ground, and when it all dried out, they had another little fire. Those roots had smoldered throughout the winter, being sealed off, and all this other, and they just kept going. And so you add a little soap to the water, and you take your chopping axe and your Pulaski or whatever, and you chop and spritz water and chop and spritz and chop and spritz, and you hope that you get everything out. But the soap will help you get the water to be more penetrative. So there is a practical use to something like this. If you can, if you can beg, borrow, or go look, Hallie's comment, and then go grab the sulfur off the high school teacher's desk or something. Sulfur works better than pepper. Pepper certainly works well. Okay? Thank you very much. Goodbye.